An amphitheater has 24 seats in the third row, 26 in the fourth. If this pattern of seat increase between rows is the same for any two consecutive rows, and there are 27 rows total, how many seats are there in total? So the first thing we want to do is understand, how is this working? Well, it's an amphitheater, right? So we can see this picture here to help illustrate what's going on. So as we get farther and farther from the stage, it curves out more and more, right? So it's pretty small near the stage, but as it gets farther and farther, it expands out and out. So that means there's more seats in every row the farther back a row we go. So later rows will wind up having more seats than early rows. That's why we've got 24 in the third, but 26 in the fourth. Right? We can see this. The early rows have fewer seats than the later rows from how far they are from the stage. Okay. So what we're looking for is how many seats there are total. So how many seats total? So what we can do is we can talk about the third row has 24 seats. The fourth row has 26 seats. So we could think of this as a sequence, right? We know that it has the constant increase. The pattern of seat increase between rows is always the same. So what we've got here is an arithmetic sequence. Makes sense since that's what the lesson is about. So we can write 24 seats in the third row. We could write that as A3 equals 24. We also know that it's 26 in the fourth row. So A4 equals 26. Okay, so if that's the case, the pattern of seat increase is the same. So the pattern of seat increase is always the same for two consecutive rows. So that means to get from 24 to 26, we added plus 2, right? We have a common difference of positive 2. So if that's the case, what would the second row have to be? Well, it would have to be minus 2 from the third row, so it would be at 22, right? 22 plus 2 gets us to 24. Same logic for the first row, so the first row must be at 20. 20, 22, 24, 26, so that's the number of seats. So we see we've got a nice arithmetic sequence here. What we're really looking to do is to take a finite arithmetic series. We are looking to figure out what is the 27th partial sum, because what we want to do is add the number of seats in the first, second, third, fourth, blah, 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 up until the 27th row, and we'll be able to figure out all of those. So what we need to use the formula we figured out is we need to know how many seats there are in the first row, how many seats there are in the last row, and the total number of rows. So how many seats are there in the last row? So A27 is going to be our last row because there are 27 rows total. So A27 is going to be the number in the first row plus 27 minus 1, right? N minus 1, 27 minus 1, times our difference. Our difference is 2, so times 2. This makes sense because what we've got here is the 27th row is going to be equal to our first row, 20, plus how many steps is it to get from the first to the 27th row? That's going to be 26 steps times an increase of 2 for every row we go forward. We work this out. So that means our 27th row is equal to 20 plus 26 times 2 is 52. A27, our 27th row, the number of seats in our 27th row, 20 plus 52 is 72 seats total. So at this point, we've got 72 seats for our final row, 20 seats for our first row. How many total rows are there? Well, that's going to be, if we're going from the first row up into the 27th row, then we can just count 1, 2, 3, 4, counting up to 27. That's easy. That's 27, right? So n equals 27. So our formula is the number of terms total divided by 2 times the first term plus the last term. So our number of terms total, number of rows total, 27 divided by 2 times what is their first term? What is the first number of seats? 20 plus what is the last number of seats? Our last term, 72. 27 over 2 times 92. We work that out with a calculator and we wind up getting 1,242 seats total in the amphitheater. Great, there we are with the answer. All right, in the next lesson we'll wind up looking at geometric sequence and series, which gives us the way to look at this through multiplying instead of just adding. All right, we'll see you at Educator.com later. Bye.